Welcome to the Energy Capital Podcast. I'm your host, Doug Lewin. My guest this week is Suzanne Leta, Vice President of Policy at Fluence. Fluence is one of the largest energy storage developers in the country, and they're doing a ton of business in Texas. One of the things I love to do on this podcast is have new technologies come on and explain what they're dealing with, what are their challenges, what are the big opportunities they see in Texas. And this one was super informative for me. I particularly liked the discussion talking about manufacturing and bringing supply chains for batteries into the United States. This is an absolute imperative in the coming years, and Fluence is really living it with different components manufactured in different parts of the country. We also talked about the technologies and how they're evolving, how lithium iron phosphate technologies have really kind of taken over, and durations are really getting extended, and we're really moving beyond the 1 and 2 hour batteries to 4, 6, even 8 and 10 hour batteries. I learned a lot from Suzanne. I'm sure you will too. You may be listening to a free preview of this episode. If you would like to become a paid subscriber to listen to the entire episode, get other paid subscriber Energy Capital Podcast episodes, access to the full archives, grid roundups, reading and podcast picks, and much, much more, go to douglewin.com and become a subscriber today. Thanks for listening. Let's dive in. Suzanne Leta, welcome to the Energy Capital Podcast.
Thank you for having me.
Yeah, thanks so much for doing this. Very interested to learn about Fluence. I've seen a lot in the press and read different interviews with folks in the company, but really excited to be talking with you today. Let's just start with just a brief introduction to yourself, what you do with the company, and what is Fluence?
Sure. I'm our Vice President of Policy and Advocacy for the Americas region at Fluence. Fluence is a global provider of utility-scale energy storage hardware and software. And I'm so happy to be here with you today. So I could talk a little bit more about Fluence as we go on.
So hardware and software. So hardware, are you guys lithium ion phosphate, some different, like what's the tech? Let's start there.
Sure. So we are technology agnostic as a company. We're always looking at different kinds of technology that would be best suited for utility-scale storage applications. But this technology and chemistry that is working best for most applications for energy storage is lithium iron phosphate, or LFP, battery energy technology. So that's the technology that we're deploying in our hardware today and for at least a foreseeable future. And what's great about it is that you can apply it for short durations, like 30 minutes, up to quite long durations, 10, 12 hours. And in all those circumstances, including what's happening most on the market today, which is between 1 to 4 hour durations, it is the most cost-effective, most dense, most safe technology in terms of battery energy storage.
So let's talk a little bit about a couple things related to that. I do want to talk about the software side too and markets and things like that, but let's just stay with the hardware for a minute. I mean, cost declines have been pretty significant, right? I mean, I think everybody's kind of familiar with over a 10-year period, like somewhere on the 90% kind of range. Maybe talk about what you're seeing, but also pretty significant cost declines just in the last year or two, correct?
Yes, pretty substantial cost declines just in the last year or two, including in markets outside of China. Within China itself, globally, those declines have been even more rapid. But yes, around the world, we've seen pretty substantial cost declines. That's good for consumers. I mean, energy storage is so important for the grid in many different ways, and those cost declines are helpful. And as a product provider, what we do is we make sure that we stay cost competitive in that environment. A lot of the declines have been the result of the cell technology improvements and the density improvements and the ramping up of LFP cell for energy storage applications in terms of the cell manufacturing scale. So those combination of things we take advantage of, right, as a systems integrator with respect to our hardware. And then where we really add a lot of additional value is the integration itself. So we're very selective about which cells we work with in terms of our cell partners. But then on top of that, we're providing an entire system to the customer. So they have one company to go to that is for the warranty and the long-term service agreement and all of that. And it's our product that we develop in-house. So it's every contract manufacturer we work with to develop our system. They're developing it specifically for Fluence. And then we add on some other really, really important features whether it's safety design or cybersecurity or the software to manage the state of charge. Those are some examples. And that's where, we really provide that added value to our customers.
Yeah. So much there I want to get into, but I want to make sure we don't lose the thread on duration because this is, I think, so important. And I hear all the time, Suzanne, from people I talk to in the energy space, but not people that are in the energy space so much, but people more that are like interested in it. Batteries are great, but they can only do an hour or two. Like they're just good for a very short duration, and that's great, but that's kind of where it stops. And you need something else if you're going to get through, longer periods. You said just a minute ago, LFP can go 10, 12 hour. I've certainly heard of 3 and 4 hour deployments, but we're really seeing up to 10 and 12. Talk about some of the durations and where you're seeing that play out.
Yeah. So I think the first thing is that in most markets where you're seeing standalone battery storage that's playing into wholesale markets, like in ERCOT in Texas, for example, you are still seeing durations in the 1 to 2 hour range. But even in states like that, we are seeing some additional interest in a little bit longer durations, like 4 hours. So that's sort of in the wholesale market dynamic where the purpose of the battery is really in ancillary services, especially. But in other markets, like in California and in many regulated markets in the US and around the world, it's actually more like a 4 hour duration. That's the standard duration. So most of what we sell is a 2 or a 4 hour duration around the world. But increasingly, whether it's because as we have more renewables and storage penetration and other power generation types of power generation on the grid, we're seeing a shift toward the need toward sort of flow 4 hour plus duration.
Yeah.
And then part of that too is being driven by AI and data center demand. And we don't need multi-day duration. There are some niche and important applications for multi-day, but really it's more of that just stretching out the availability a little bit longer in the 8 to 12 hour range. For example, in California, in the integrated resource plan modeling they do for the utilities, they have sort of a variety of different technologies that they look at specifically for 8 hour duration.
Interesting.
And so, what's great about lithium iron phosphate to serve that need, that 8 hour plus need up to around 12 or so, is that it is actually much more cost competitive than pretty much any other technology, in part because of the cost declines that we've seen more recently to meet those longer durations. And they don't necessarily need the charge and the discharge to be synchronous. You can have asynchronous charging and discharging. And that's where the LFP benefits really come in.
So, and I want to come back to Texas in a minute. Obviously, the podcast about Texas, but this is very interesting. If you're doing a integrated resource plan, and for folks that don't know what that is, a lot of utilities, particularly if it's sort of centrally planned or vertically integrated, and California is sort of somewhere in between, but they'll do these kind of long-term plans where they set different resources up next to each other. So you're basically saying, like, if you set whatever the longer duration resource is, whatever you might think of as a long duration resource, and you stack it up against an 8 hour or 10 hour or 12 hour battery on cost, the 8 or 10 hour, 12 hour battery is beating like what other kinds of resources, or did I not understand?
I would say it's beating other types of storage technology resources
Got it.
that
Got
have
it. Okay.
usually been thought about as the only way to serve that longer duration,
Very interesting.
and particularly when the charging and discharging is asynchronous.
Okay, got it. And I will say too, I think it's very interesting in ERCOT because it is obviously an energy only market. And you are seeing a whole lot of really 2 hours. In the beginning, I think it was a lot of 1 hour.
Yeah.
It got stretched to two. Now we are seeing CPS Energy is developing, it's actually 500 megawatt over 2 gigawatt hour, couple of different batteries and battery sites, but all kind of close to each other. And I think we're going to see more of that because obviously I'm a nerd and I watch the ERCOT app almost on a daily basis. And there are a lot of nights now where you get this sort of like, yes, there's the 2 hour peak of batteries, but sometimes, particularly when there's a lot of thermal outages, a lot of the gas plants are offline for maintenance, you'll see almost these like secondary spikes, like 3 hours after the initial sort of peak. There's a signal that is, I don't know how strong it is or whether it's fully coming through yet, but I think there's a signal there that like, hey, if you're a battery that can actually go beyond two, there's probably some money for you to be made there because there's so many 2 hour batteries and they're kind of spent within that period.
I think that's a great point. And I think that's the thing about storage in particular in terms of how it plays in markets. One, of course, is that storage in itself is energy agnostic, right? It can pair with a fossil plant as well as it can pair with, or fossil on the grid, either, as well as it can pair with wind or solar assets. But as what is on the grid itself, the power generation resources evolve, and also how much storage is on the grid, the storage duration of, especially for new projects, and the revenue generating capability based on that duration does change over time.
Yeah. You mentioned at the beginning that y'all do hardware and software, and I think obviously that's, almost anybody. There certainly are companies that are just hardware, but if you're a developer putting something on the grid, you have to have the software solution now too, obviously, because again, I look at that ERCOT app way too much. There are times when prices are high and I see people charging, and you can see batteries, like you could see it on the dashboard. And I just think, well, somebody's got software that's not working right. So you guys have sort of tackled this on the front end that, like, we're going to get the hardware right. We're going to focus on that. We're also going to get the software. Can you talk a little bit, and specifically, again, most people listening are interested in Texas. So Texas, obviously, with like 5-minute dispatch and just a very dynamic market, so much renewables, a lot of variability. So I assume the software is really watching that in real time, and then charging or discharging the battery based on the real time circumstances.
Thank you for listening to this free preview of the Energy Capital podcast. You can access the entire episode as well as the Texas Energy and Power newsletter archives at douglewin.com. That's DOUGLEWIN.com. You'll also be able to attend paid subscriber-only chats, and you'll receive full access to all of the Texas Grid roundups and reading and podcast picks. Please check it out, and thank you for listening.